Good morning, class, and welcome back to the channel. Today we are going to be continuing the worksheet that we started in the last video. Once again, there is a link to a PDF of that worksheet in the description. Please feel free to click it and follow along. In the last video, we focused on equations in standard form, but this equation is clearly not anywhere close to standard form. The equation we're given is y squared plus 4x minus 20 minus 2y equals negative x squared. And I don't hesitate to say this is a mess. Here's the standard form equation that we looked at last time. As you can see, what we've got here looks absolutely nothing like it. If we had it in standard form, we'd be able to pick out the center and the radius really fast and then graph it. And the method we're going to use to put this expanded form of this equation into standard form, the technique we're going to use, we've used already in the past, and not that long ago. Okay, so here I've rewritten my equation, and I'm ready to get started turning it into standard form. Now, the technique I'm going to use is one that you have used before. So here's what I'd like you to do. I'd like you to follow along with the video and what I'm doing, but once you recognize what it is that I'm doing, I'd like you to pause the video and try to finish the problem out on your own. You really do recall things better when you recall them on your own rather than watching someone else do it. It really will make it easier for you to recall in the future if you make the attempt on your own before watching me finish the problem. So the first step in this process is going to be to separate out the variables and the constants. Everything with a variable in it is going to be over here on the left side, whereas everything that's just an ordinary constant number, we're going to move over to the right side. Now, because you're coming up on the end of integrated math 2, I'm going to go ahead and do this moving around in just one step, so don't freak out. I'm adding 20 to both sides to move that constant over, and I'm adding x squared to both sides to remove it from the right side. So after step 1, I end up with x squared plus y squared plus 4x minus 2y equals 20. Haven't changed anything, just rearranged stuff a little bit. Step 2 is to look at this left side of the equation, and we're just going to sort of rearrange things to group up the x's and the y's, giving us x squared plus 4x plus y squared minus 2y equals 20. Once again, I hope you can all see I have not changed anything, I'm just rearranging stuff. Step 3 is an optional step, but it's a thing that I do to help me stay structured. I add blanks to the equation so that it looks like this. So I put a blank after the 4x and after the negative 2y. Now, recalling that what I need in the end is x minus h squared and y minus k squared, what I need is a couple of perfect squares. I don't have perfect squares right now, but I can add to both sides of the equation to get my perfect squares. I really hope this is starting to look familiar. Let's focus just on the x's for a moment. We've got x squared plus 4x plus blank, and we want that to be x minus h squared. So we need to find some number to put in that blank that will make this trinomial a perfect square. We're going to take our linear value, 4x, we're going to take that coefficient 4, divide it by 2, and square it, If you don't remember why we do this, I will go ahead and add a link up top. 4 divided by 2 is 2, so we're going to end up with x plus 2 squared. But in order to get that x plus 2 squared, we have to add, well, let's see, 4 divided by 2 is 2, squared is 4. X plus 2 squared is the same thing as x squared plus 4x plus 4. But in order to get that, we had to add 4. And if you add 4 on one side of the equation, you have to add 4 on the other side of the equation. Now let's turn our attention to the y's. Forget the x's, they're done with, we're there. Let's turn our attention to the y's. Exact same process. Our linear value is negative 2y, so we're going to take that coefficient negative 2. We're going to divide it by 2 to get negative 1. So our square is going to be y minus 1 squared. And the number we have to add to both sides, well, let's see. Negative 2 divided by 2 is negative 1. Squared is positive 1. In order to make this y minus 1 squared, we have to add 1. And if we add 1 to the left side, we have to add 1 to the right side. So step 4 is to complete the square twice. So now we've got our standard form equation. Let's zoom out and take a look at the whole process. There isn't really anything new here. You already know how to manipulate equations. You already know how to complete the square, or at least we've done it before. This isn't really new information. And now that we have our equation in standard form, we can say that the center is negative 2, positive 1. If you don't know where that center came from, you might want to take a look at my last video. I'll go ahead and drop a link right now. Of course, the other thing we need to know is the radius. Since 25 is 5 squared, the radius is 5. So let's go ahead and see if we can't graph this. The center is at negative 2, 1, so there's the center right there. And I need my circle to have a radius of 5, so let's see. 1, 2, 3, 4, 5. That's about right. I'd say that's about right. Now, as I mentioned in the last video, it's probably a good idea to write down these steps in your notes, because for the next 3 problems, I'm not going to be writing all the steps down, I'm just going to be doing them. Okay? So, pause the video, take notes if you have to. Let's move on. Number 6, negative 9 equals negative y squared minus x squared. This is another one of those times when a lot of students will immediately panic because this looks different than the previous problem, but it isn't different from the previous problem, I promise. Here's my equation, negative 9 equals negative y squared minus x squared. Well, I don't like all these negatives flying around. I really prefer positive numbers where I can manage them. So I'm going to go ahead and multiply each side of the equation by negative 1. And while I'm at it, I'm going to go ahead and flip-flop their order as well. It's an equal sign, I'm allowed to do that. And with that, we are in standard form. That was it for that one. Wait, what? Was it really that easy? I don't see a 3x or a negative 2y or anything like that. Yeah, don't freak out because it's easy. Not only do we have an entire video about why this is the equation of a circle centered at 0, 0 with a radius of 3, we can also rewrite it to look like this. Do you see how once again I have not changed any part of the equation's value? I just changed the way it looks by highlighting those zeros that are always there, but we just don't write them down because they'd be redundant. So our center is 0, 0, and our radius is 3. I bet I can graph that pretty easily. There's the center. And there's my radius 3 circle. Let's move on to number 3. Number 3 for this video, which is actually number 7 on the worksheet, is 9 equals 2y minus y squared minus 6x minus x squared. Okay, let's go ahead and copy this equation down and see what we can do with it. So here's our equation, and all I've done is flipped it around. And it actually looks like we've got all of the pieces we need right now. Let's see. All of the x's and y's are already on one side. I still don't like those negatives though, so I'm going to go ahead and multiply both sides by -1 again. Now remember, when I multiply both sides of this equation, since all of these things on the left are being added and subtracted, I'm going to distribute that -1, and I'll go ahead and get all of the terms in an order that I like as well. So I multiplied everything by -1, and I put it in the order y squared minus 2y, because that positive 2y was multiplied by -1, plus x squared plus 6x equals -9. Now my next step is to go ahead and add some blanks to give myself a visual reminder that I need to complete the square. I went ahead and added some extra parentheses as well, just to remind ourselves that we are looking to complete two separate squares. We take the number in front of the y, -2, divide it by 2 to get -1, which means we are going to end up with y minus 1 squared. But in order to get that y minus 1 squared, we have to add, let's see, -2 divided by 2 is -1. -1 squared is +1. If we add 1 to one side of the equation, we have to add 1 to the other side of the equation. How about the x's? Well, we've got this 6 in front of the x. We divide it by 2, which gives us 3, so we know that we're going to end up with x plus 3 squared. Now to figure out what do we have to add to both sides to make that perfect square happen, well, we take that 6 and divide it by 2 to get 3, and then we square it to get 9. X plus 3 squared is equivalent to x squared plus 6x plus 9. But again, we can't add 9 to one side of the equation without also adding it to the other side of the equation. So our standard form equation is y minus 1 squared plus x plus 3 squared equals, well, let's see, -9 and +9 effectively cancel out, so equals 1. Our center is +1, -3. And our radius, well, heck, what's the square root of 1? Yeah, it's 1. All right, let's see. The center is 1, -3. That's that point right there. And the radius is only 1. This is going to be a teeny tiny little circle. And that's number 7. Once again, pause the video if you need to take notes. Otherwise, I'm going to move on to number 8. All right, number 8 says 16 plus x squared plus y squared minus 8x minus 6y equals 0. All right, same deal. First thing we're going to do is recopy the equation. So I went ahead and copied our equation, and because this is the 4th problem, I'm going to go ahead and start picking up the pace. Step 1, separate variables and constants. Step 2, rearrange the left side so that the x's and the y's are together, with or without the parentheses and the blanks as you prefer. Find out how many you have to add to each group to complete the square. Don't forget to add those values to both sides of the equation. And finally, rewrite the equation with the perfect squares. Take a moment, write it down if you have to. And hey, what's the center and the radius? Well, let's write that down too. The center looks like it is +4, -3. And the radius, well, if 9 is r squared, then r is 3. So let's go ahead and take a look at the graph. All right, 4, -3 looks like it's right about here. And there is my circle with radius 3. So there you have it, 4 examples of how to take the equation of a circle that's in expanded form, which isn't very useful, and convert it into standard form, which is much more useful. If you want to think of it this way, you could call this center form, since it gives you the center and the radius very quickly. In the next video, we're going to go ahead and finish up this worksheet, and I will see you then. Take care, stay safe, class dismissed.